Match each statement with the correct, match each item with the correct statement. Anytime you're given some of these, I like to start with the definitions and then go over here and find the matching statement on the left-hand side, the one word. So the first one we're looking for is a large explosion on a star that makes it brighter. Explosions on stars that make them brighter, they're called novas. And we have regular novas and we have supernovas. Supernovas when we have a high mass star at the end of its life. When it's done fusing material, it actually has iron in the core and it can't fuse iron. And gravity starts to win and it tries to collapse the star and it bounces off the core of the star and it explodes in a supernova explosion. And that bounce actually, there's such a tremendous force that the protons and neutrons are forced together in the core. And of course, when you have a positive and a negative and you force them together, it forms a neutron. And so those are called neutron stars. Regular novas are a little less dramatic, but they're if you have a binary star system, usually there's two stars there close together, and a lot of times you'll have a white dwarf and a red giant, and the white dwarf will start to pull material off of the red giant with its gravity, and that material will settle onto the hot outer skin of the white dwarf and it become very unstable, and there'll be smaller explosions because of that. But any explosion or brightening of a star with that explosion, they do call them nova. The large clouds of gas and dust where stars are born, well, those are nebula. Don't get nebula and nova mixed up. They both start with N. But a nebula cloud, the nebula hypothesis is where we understand that all stars are born. The dense collapsed star with electrons and protons smashed together to form neutrons. Well, we just talked about that. Those are neutron stars. And again, they happen in those supernova events where the big stars collapse down and bounce off the core and smash those protons and neutrons, protons and electrons together to form neutrons. Spinning region in space with a concentration of matter heated by friction. These are the protostars. This is when that nebula cloud is spinning and flattening together. There's going to be a lot of dust in it, and it starts to rub against each other and heat up due to friction near the center of that nebula cloud. And that's where your protostar is going to be born. A protostar, it's not a true star. It's kind of like a prototype of a car, is the first edition of a car, but they'll come out with later models later on. The protostar is the beginning of the star where it's heating up due to friction, and then when enough heat accumulates, that's when nuclear fusion can begin, and that's when they say it becomes a true star, and it sits on the main sequence for most of its life after nuclear fusion begins. But this is the earliest edition. And then finally, an object so dense where light cannot even escape. Well, that's the black hole. Black holes are where even these are the largest of the stars. The bigger than the ones that make supernovas, because what will happen is they too, at the end of their life, nuclear fusion will end. They'll have iron in their core, which can't be fused together and release energy. And the star will try to bounce and try to go supernova, but it's just too massive. There's too much gravity there, and it actually pulls the star back into a singularity. And the density of that material is so great that it actually bends space and time itself, and light can't even escape from that.